Hello everyone, I'm Dr. Munibashwak and today we are going to start programming in C++. These video lectures are going to be beneficial for those who have just started learning programming or those who want to become expert in programming later on. To excel in any field, you have to start from some point. So let's get started. The reference book that I will consider in this video lecture is C++ How to Program by Detail and Detail. Here is today's agenda. We will talk about why we need programming language, what are the different types of programming languages, and what is C++ programming language. We will also talk about procedural versus object-oriented programming. What are the basics of typical C++ environment, the basic structure of a C++ program, and we will be looking for some examples, like printing a line of text. There are multiple ways of doing that. So the question arises why we need a programming language. Before answering this question, let me answer the question why we need a language. So the language I'm talking about is among human beings. While living in this world, we have to share our ideas, thoughts, and feelings with others. For that, we need a way of communication. So for this purpose, we need a language. There are different types of languages like English, Spanish, German, French, Japanese, Urdu, Arabic, and many more. What if this communication is in between a human being and a computer or a machine? So what type of language we will be going to need if we want communication with the computer? What language a computer understands and why we need it? Computers are used for several purposes, like online bill payments, watching movies, social media access, playing games, internet access, and many more other facilities we have. We want computer to do certain tasks for us. All these facilities have been provided to us through computers via programming. Even a single click have a program behind it. So we need programming language to communicate with computer to provide us with certain facilities. If we want a computer to do a certain task, we have to program it. If we want to give instruction to the computer, then it can only understand via programming language. Any computer can directly understand only its own machine language defined by its hardware design. Machine language generally consists of strings of numbers ultimately reduced to ones and zeros that instruct computers to perform their most elementary tasks, one at a time. So initially, all the computers were programmed using machine language, and that was very difficult and cumbersome for a programmer to remember these strings of ones and zeros to perform a certain task. Ultimately, only small programs can be written. The lowest level is the machine language level. These consist of different machine codes to perform a specific task. These are directly processable and understandable by the computers and machines. These are written in the form of ones and zeros or in the binary form. On one hand, it's really easy and understandable by the machines and the computer. But at the other end, it's really hard for a programmer to read and to remember these strings of codes, and it's really slow to create, but it's fast to run for their computers. The next level, which is a little higher than the machine language, is the assembling language. So instead of using the strings of numbers that computer could directly understand, programmers begin using English-like abbreviations to represent elementary operations. These abbreviations forms the basis of assembly language. And these abbreviations are called the mnemonics, which directly represent the machine codes. So here is an example of that. Like we have some English like abbreviations to do certain tasks, like move, INC for incrementing a value, J and Z jump when the value is not zero. So these are little better version as compared to the strings of ones and zeros. So in terms of programmer, we have this version which is easy to remember and understandable for a programmer. But still, it's slow to create and it's processor specific. Uh, Still, at this point, we need some programs, some translator programs, which are called assemblers, and that are used to convert any assembling language programs to machine language, which is understandable by the computer. To further speed up the programming process, higher level languages were developed. The translator programs here are called the compilers, which convert high-level language programs into machine language. And the examples of high-level languages, we have the Pascal, C, Fortran, C++, Java. Here, one statement is equivalent to many machine code operations. So it's easy for a programmer to write the instructions for a program. So here in single statements is equivalent to many machine code operations. It's more human understandable and it's fast to write. This is an example of a high level language, and this is one of the sample of the C++ program. This program is called the source code, and ultimately it have to be converted into the ones and zeros, which is the executable code. So this process can all be done by the compilers and linkers that translate a high-level program into the executable machine code. C++ programming language. This is high-level programming language developed by Bjorn Stroustrup starting in 1979 at Bell Labs. C++ runs a variety of platforms such as Windows, macOS, and the various versions of Unix. It's an extension of C programming. It has an object-oriented programming feature. Procedural versus object-oriented programming. Procedural programming language is an important programming language whose programs have the ability to be primarily structured in terms of reusable procedures, for example, subroutines or functions. So in procedural programming language, we have the codes which are reusable, and these are the procedures and the functions. But in object-oriented programming, this is a programming paradigm based on the concept of objects. So we have to create an object which may contain data in the form of fields, often known as attributes, and the code in the form of procedures known as methods. Now let's come to our basics of typical C++ environment. It consists of different phases, starting from edit, preprocess, compile, link, load, and execute. So this is the complete workflow, which is also shown here. In the first phase, which is written over here, this is the editor. So edit phase, and you can see that we have the editor here for this phase. You have to edit a file with the editor program, and you have to, after making some necessary changes, you have to save your program on the secondary storage device such as your hard disk, and you have to save your file within an extension .cpp, which shows that your program is in C++. In the phase 2, you can see that we have the preprocessor for the phase preprocess. So you give command to compile the program, but in C++ program, a preprocessor program executes automatically before the compiler translation phase begins. So we call pre-processing as the phase 2 and compiling as the phase 3. In C++, preprocessor obeys commands which are called preprocessor directives. which indicates that certain manipulations are to be performed on the program before compilation. These manipulations usually include other text files to be compiled and perform various text replacements. In the phase 3, which is the compile phase, you need a compiler for that. So compiler translates the C++ program into machine language code, also referred as object code. Phase 4, which is the compile phase, you need, the phase 4 Phase 4 is the link phase, which needs a linker. So in phase 4, linking C++ program typically contain reference to the functions and data defined elsewhere, such as in the standard libraries or in the private libraries of group of programmers working on a particular project. The object code produced by the C++ compiler typically contain holes due to the missing parts. A linker links the object code with the code for the missing functions to produce an executable program with no missing pieces. If the program compiles and links correctly, an executable image is produced. So a linker is basically used to link the object code with the code for missing functions to produce an executable program. And the phase 5, which is the load phase, you need a loader for that. Before a program can be executed, it must be first placed in the memory. And this is done by the loader, right? Which takes the executable image from the disk and transfer it to the memory. Additional components from shared libraries that support the program are also loaded. Finally, the computer, under control of its CPU, executes the program one instruction at a time. This is the structure of a C++ program. As I've already told you that the C++ program consists of 3 main parts. I've already told you the preprocessor directives here. You can see that we have the preprocessor which obeys the commands by the preprocessor directives, and these preprocessor directive starts with this hash. So you can see this is a sample of a C++ program. Hash include IOStream, and here the second main part is the main function. So you can see that this is the main function. This is the entry point of your C++ program. This is the point where your program start execution, right? Then you have, you can see that within this brackets of this main function, you can see that you have multiple statements which are called as the C++ statements. So when you execute this program, which is written over here, hello world will be print on the output. So this is an example of how you will be able to print the word hello world. So you can see that first of all, you have the standard input output library of procedure, and hash include IOStream, input output stream. So this is basically from the file from the standard input output library to perform input and output streaming, right? Then you have the curly brackets, which is the beginning and which is the beginning of this main function and the ending of this main function. And within these two curly brackets, we have the main C++ statements where you start your programming. This is std cout hello world. You can see that this std is the function call to output hello world, std cout. So this basically cout stream object is from the namespace std. And every C++ statement ends with this semicolon. Standard output stream object std out. This is connected to the screen. So whatever you want to print on the screen, you have to use this output stream object. And in combination with this output, you have to write this operator, which is also called stream insertion operator. You can see that after cout, we have this stream insertion operator. Value to the right operand inserted into the output stream. Now come towards the namespace that we are talking about. STD, which specifies using name that belongs to the namespace STD. You can also write here after this hash include IOStream, you can write here using namespace STD, and then you write a semicolon after that. And then in this case, you don't need to have to write this STD and scope resolution here. You have to just write in this case, cout hello world. But if you have not written here using namespace STD, then you have to write here STD scope resolution, which is shown in this example. Escape characters. It indicates the special character outputs. As you can see that \n, which is used for new line, \t, it's used to produce a horizontal tab. \r, if you are using \r, it is for the carriage return. Position the screen cursor to the beginning of the current line and do not advance to the next line. \a, it is for alert, sound the system bell. \backslash is used to print a \/ character. Then if you want to use the double quote, then you can use this / double quotes. Now come towards the actual programming. This is the example where we are going to print the welcome to C++. This is the example. This is the first example that we are going to print the hello world in a single statement. We have written here std, scope resolution, cout. Then you have the stream insertion operation, and within these double quotes, you have to write the string that you want to print on the output screen. And then you have to write this semicolon. But in this example, you can see that we have written welcome in first C++ statement, and in the second C++ statement, we have written again the remaining of the string. Like you have the complete sentence, welcome to C++. So you write half of the statement in one C++ statement and the other remaining only as the second C++ state. But the output when you execute and when you execute this program, welcome to the C++ will be displayed on the screen. In this example, in this example, you can see that we have written here welcome \n to \n C++ apostrophe. We have okay, in this example, this is an example which is related to printing multiple lines with a single statement. So you have a single statement here. You are going to output welcome to C++, but in between welcome to C++, we have \n. And what was the purpose of \n? You can see that \n is used to create a new line. So when we execute this program, first of all, whatever is written within these double quotes would be displayed as it is on the console. So first word is welcome. Welcome is printed on the screen. Then you have the \n. So cursor will move to the new line. And then when the cursor moves to the new line, we have the word to. So 2 will be printed on the screen. After that, we have \n. So the cursor will move to the new line, and then again we have \n. So again, cursor will move to the next line. After that, we have the C++. So C++ would be printed on the screen. Even after C++, we have again \n. So the cursor will then be moved to the next line again. Now we are going to write a C++ program in code blocks, which is IDE, Integrated Development Environment. So it's a complete software package which includes all the steps for editing, pre-process. You have the linker, you have the loader here. You can execute your program. So you don't have to do much care about how to compile your program. You just have to start writing your program in this IDE. First of all, you have to write your C++ program. For that, you need your editor. So it's very easy here. In code blocks, you have to select a file, new file. So go to the file, then in the new option, select this empty file. So this untitled empty file has been opened. Here you have to start your writing your C++ program. So we are going to write a C++ program. First of all, we have the preprocessor directives, which is hash include iostream, right? Then you have using namespace std, write the semicolon here. The second part of your program is the main function int main. So just remember that you have to write these round brackets after this main function, as if this is the function. After function name, you must have these round brackets. And the body of this main function starts with these curly brackets. So this is the start of the main function, and this is the end of the main function. Within these curly brackets, you have to write your C++ program. At the end, you can see that this is int main, so it's going to return some integer number. For that reason, we write here int return 0 semicolon. So let's save this file. Save file as. You have to save your file, give it some name like range underscore line, right? Dot cpp. Save it. Then you can see that first it was an untitled text file. Now I've saved this file with an extension .cpp, which shows that this source code belongs to C++ program. So within this main function, we have to write whatever program that we want to write, right? So as we want to print some line on the output screen, so we have to write C out, then stream insertion operator. Within these double quotes, we will write whatever we want to display on the screen. So after these double quotes, we have to write this semicolon. Now, have a look on this program. You have the three main parts. Hash, these are the preprocessor directives. Starting with hash sign, you have the main function, and within the main function, you have the C++ statements that is the purpose of writing your program, right? So you have to be careful for each and every point here, that you have to write here semicolon. There is no semicolon here, right here. uh, round brackets after main. Here is curly brackets, right? And at the end of the C++ statements, you must have a semicolon at the end. Here you have the, as you want to print something on the screen, you have to write C out and then look at the shape of the stream insertion operator, right? And then within this double quotes, write the string, whatever you want to print on the screen. So here I want to print welcome to C++. Save it, build this program, run this. You can see that it have 0 errors and 0 warnings. Now let's see its output. This is the output. Welcome to C++. So we have written this string welcome to C++ within the within the double quotes. Now come back to our C++ program. Now we will do some changes. Here we are ending up our C++ statement after welcome and writing another C++ statement for this welcome to C++. Now save the changes again. Build your file, run this program. Now you can see the output. You can see that still welcome to C++ have been written within a single line. So even though I have written these statements on separate lines, but it have no effect on the output. What is going to make an effect is that if I want to print two C++ in the next line, I have to write \n to emphasize that there should be a next line. Two C++ should be printed in the next line. So save it again, build it, run the program. Now you can see that you have the output, which is welcome in one line, and in the next line, two C++ is written. Coming back towards the program. Now I want to do some more changes. Now I want to use \t, build this program, run it. Now you can see that there is a space in between welcome and to. Now coming towards the program again. Now I want to use check the use of \r. After running this program, you can see that first of all, welcome was written on the screen, but when the compiler says \r, which means that there is a carriage written, so the cursor will move back to the start of the same line and will write to C++ on the previous previous written welcome. So you can't see the word welcome. Instead, you are only seeing this to C++ because of \r, which was the return carriage. Now coming towards back to the program to see more effects. Now what I want to do, if I want to include a backslash in the text, so what I have to do, I have to write here backslash backslash. Save the program, build it again, run it. Now you can see the output. Now after welcome, you can see a backslash as a text in the in the print, right? Coming back towards the original program to see more facts. Now what I want to do is I want to let's suppose I want to include welcome in the double quotes. So what I will do, I will write here backslash double quote and backslash double quote. Now let's check the output. You can see that welcome is now enclosed in double quotes.